Still start. Okay, let's start. Aram se get sir. So refraction in say daily life. Total internal reflection is not in your course. I taught you just for your interest perspective. Refraction in daily life. First, what we will see is why does the swimming pools, the depth of a swimming pool appear less to us. So let's see that. Okay. So let's say this is the floor bed of a swimming pool. Okay, children, this is the floor bed of a swimming pool, and this is the water level of the swimming pool, right? So what is the actual depth of the swimming pool? This is the actual depth of the swimming pool. Okay, so इसको I am writing actual depth. Fine. Now what is this medium? This medium is water. So I'm just mentioning this as water. And what is this medium? This medium is air, right? So the swimming pool will appear at a lesser, this is the actual depth. But when you go to a swimming pool, you feel that the depth is less, swimming pool upar hai, right? Now that happens because of refraction. Now where will the rays come out from? The rays are coming from the bottom. So this is a rarer medium. So rays coming out from rarer, and it is coming to, from rays coming out from denser, and it will come to a rarer medium. So the tendency is to gain speed, right? And move away from the normal. So what I'm doing, right? I am creating two rays from the bottom of the swimming pool. Let's say this is the bottom of the swimming pool. This is my first ray, right? And from the bottom of the swimming pool, I am having another ray. Is this much understood? These are the two rays which are coming out from the swimming pool's bottom, right? Now what I do, I have reached the interface. This portion can also be treated as my interface, and at interface they are incident. So what I'll make at the interface, I'll make two normals. So this is normal one. So let's say this is one normal, and this is one more normal. Asha, allow some time for me also to get normal. I actually got a lot of scolding at home and I have come. So my temperament is also not, because I did not have my breakfast. And my mother scolded me saying, why can't you take care of your class timings? All because of Amish. अगर ये तेरे लिए आज सुबह डोज गिरा है घर पे, ठीक है? चलो. Now this is my incident ray. This is my incident ray. ठीक है, children? I'm writing. These are my incident ray. Now refracted ray. एक भी बार पढ़ के आया, मुझे कितना मजा आ रहा है, कितना तुम enjoy कर रहा है क्लास को. This is my refracted ray, and the refracted ray will bend away from the normal. This is the refracted ray, right? And similarly, I will have one more refracted ray which will also bend away from the normal. This is the refracted ray, right? Now these rays are what, beta? They are divergent rays. Will they ever meet? They will not meet. So what we do, we extrapolate them backwards. So I'm extrapolating the first ray backwards here, and now I'm going to extrapolate the second ray backwards here. All right, and both the rays are meeting at which point? Both the rays are meeting at this particular point. Have you understood? And from this point now, I create another level, and this is now the this will be now the apparent depth, not this one. Please be very careful. Depth has actually raised up now. This is now the apparent depth. So if you are the observer, and this is your beautiful eye, right? This is your eye. How do you see the swimming pool? You see the swimming pool's depth was actually at a point P, which has now moved to P dash, right? And let's say exactly how to say it. So let's say this was actual depth, ACD, and this is AAD, apparent depth. ACD is my actual depth and AAD is my apparent depth. In grade 12, you will be doing calculation also. Very easy. It is actual depth divided by the refractive index. Then you get your apparent depth. Have you understood? Anyone who has not understood, please let me know. We can discuss once again. So the swimming pool's floor has now come up from this level to this level. Anyone who has not understood? Yes, Shreya, bolo betu. Okay, I'll explain the diagram again. Okay, so look, I'm putting some marks on it. Okay, I'm putting some marks on it. Let us say betu XY is the bed of the swimming pool, the floor of the swimming pool, right? And P is a point on the floor. So when you go to the swimming pool, you actually feel that the swimming pool is of lesser depth. When you put your leg inside, you actually go, you feel the actual depth. So what happens? Two rays are coming out from P, right? In order to see P, in order to see the point P, rays from P has to come to my eyes, right? Now, how are the rays traveling? How do we see an object? We see an object because the object reflects the rays back to our eyes. Now my object is this point P, Shreya. So from point P, a ray comes out, and this ray comes out and hits the water air level, which is known as the interface. I'm unable to change color here. So this is my interface, and it is coming out from a denser medium. Then it hits the interface, and then it's supposed to go at rarer, so it will bend away from the normal, right? This had to be the actual course of the ray. The ray has bent away. Similarly, the ray has bent away this side also. They become divergent rays. Divergent rays will never meet, but I need to get an image. So how do I get an image? I extrapolate the rays backwards. And once I extrapolate the rays backwards, I get the red dot. If you're able to see the red dot. The red dot is the new point P dash, which you as an observer from above get hallucinated with. You feel that the depth is at this. So this was my actual depth. This is my apparent depth. Many children in exam do a mistake of writing this as apparent depth. This is not apparent depth. This is loss of depth. ठीक है? ये खाली केयर रहना. बहुत लोग ये mistake कर देते हैं. This is loss of depth. This is apparent depth. Is this fine? So this was our example where what we say, the depth of a swimming pool, the depth of a swimming pool appears less than what it actually is. So actually it is the actual depth, and the depth which has got reduced, and the new depth will be known as the apparent depth. Bacha, clear on this one? Our next example will be a stick dipped in water appears bent. A stick dipped in water appears bent. Shall we see that example also? हाँ, आराम से करो, कोई टेंशन नहीं है. Just ask yourself a question that you should be able to answer why this happened and how to draw the diagram. And once this is done, we then move into what is known as lenses. Lenses is again interesting, but remember, mirror में हमने किसको ज़्यादा पढ़ा था? Concave. Lens में किसको पढ़ेंगे? Convex. And we will read concave lens very less. It becomes more interesting when you learn about the eye, because that's practical application. Can I just start writing? So this was our first observation. Our second observation will be about a stick dipped in water just 1 minute. Huh? You write. Let me just make one call. Jia, hello, hello. তুই যখন আসবি না, just done. Okay, our next example: a stick dipped in water, or it can be any fluid, appears bent. Bent at the surface. Okay, so let's see. So for this, again, same example. What I'm doing, okay, you want the beaker to be drawn, so let's draw the beaker. Right, this is a beaker, and on this I have a water surface. This is the water surface. Let's say this is the water surface, and you have dipped a stick in this. You have dipped a stick in this. I say you have dipped a stick in this. Correct? Now, the stick will be appeared bent to us. So how this happens is, now the rays will be coming out from the tip of the stick. The rays will be coming out from the tip of the stick. Let's say this is one ray, and I should have another ray. So this is my other ray. These are the rays which are coming out from the tip of the stick. Try to understand, children. I have dipped a stick out here. So let me label. Let's say AP is my stick. AP is my stick. And two rays are coming out from P. And they are hitting the interface. Same with the example. This is H2O and this is air. That means you are going from denser to rarer. And then how does the bending happen? Now we will have two normals. Let's make two normals out here. So the first normal is here, and then I should have one more normal, and the second normal is here. Okay, till now fine, two normals. Now the rays will diverge out because they are going from rarer to denser. The rays have diverged out. This ray will also diverge out. And once the rays diverge out, I have no other option but to extrapolate them to find from where they actually diverged. I will extrapolate them. I have extrapolated the first ray and I'm extrapolating the second ray. And these two rays now meet at a point, and my new point is, this is my new point where it has met. And this new point I am referring as P dash. This is P dash. And children, now I'm changing a color. It may not be straight, otherwise you'll get confused. My stick will now appear like this. Sanjaya? Yeah, 1 minute. Yeah, why not? You all are actually busy drawing. First, try to understand the logic, then you will be yourself able to draw. Don't try to draw initially. First, try to appreciate the logic. I have a stick AP which is bent, right? And there is a point, say D, from where it is submerged in water. There is a point D from where the stick is submerged in water. Clear? Now the tip of the stick is P. The tip of the stick is this point P. Is the point P. Let me put it like this. Is the point P. And from point P, two rays are coming out. What are the two rays? This is one ray and this is one ray. These two rays are coming out. And they are coming out from a denser medium. they hit the interface. After they hit the interface, they are going to move away from the normal because they are coming to rarer surface. Air is rarer, so they move away. So both the rays diverge out now. They diverge out like this. So in order to get an image, the rays have to intersect, but they are not going to intersect upwards. So I extrapolate them backwards, and I now get a point P dash, which is my point P dash. This is my new point, say P dash. This is the new point P dash. So the stick appears for us to be straight from A to D, and D to P dash, the stick appears bent to you because you are observing from the top. Did you get the logic now? Still unclear or what? Tell me, don't hesitate. I am there to explain. No, you are again not listening. If you listen, you will get it. See, don't get, I'm not angry at all. Okay, you can ask, but listen first. P dash is an apparent point. It is a virtual point. Why do I call it virtual? Because P dash has been formed by the intersection of two rays which have actually not met. Do you agree that or not? P dash is formed by extrapolating two rays. Do you get it? And P dash is the point which is inside water itself, apparently. For the viewer, beta aap aise upar se dekh rahe ho, you are looking from the top. So when you look from the top, the P dash is somewhere inside the water surface. And it is the same example, like the bottom, some bottom level got elevated, some bottom level got elevated. Got it? Swimming pool mein, there was no stick. Had you dipped a stick right to the bottom of the swimming pool, then the stick would have come bent till the point P dash. Are you understanding? Actually, I have drawn this diagrams very geometrically correct. I'll draw some crude diagram. Now it will become easy for you. Dekho ek baar. This is my swimming. This is my swimming pool bed. Okay. This is my swimming pool water surface. Two rays come out from the bed. Just observe, huh? Anurag, two rays come out from the surface. There are two normals out here. These rays diverge out. These rays diverge out. They are never going to meet. So I bring the rays backwards. And this is the new level of the swimming pool. Have you understood? Now in this swimming pool, beta, you dip one stick. This is the stick that is dipped. Right? Now I'm using red color. The tip of the stick has now come here. Do you agree or not? If the floor bed has come up, the stick has also come up. And for you, the stick will appear seedha, straight, bent. Because you are watching from the top. Is it clear now? Now he is. When I ask him. So, is this clear now?
Yes, sir.
Okay. So, these were some of the impacts of, if still someone has not understood, don't go by my temperament. You have full right to ask. My temperament is because of a different reason, because of the dosing. Ajay, you tell me, so have you understood? All of you, clear? Why does a stick appear bent? Why is the swimming pool? Why does the depth of the swimming pool appear less? Understood? Somebody might ask, change this example to a coin dipped in a glass of water appears to be at a higher height. Elevated. Same clause. Ultimately, where are the rays originating from? Water. Water is a denser medium. Air is a rarer medium. So it will always diverge. At this level, we conclude everything that was related to laws of refraction, Snell's law, absolute. Now we go into lenses. Are we ready? Anything, any pencil, if I dip you also straight, I will see you half bent. Anna? But tell me, if the pencil is fully dipped in water, then you won't see it bent. You will just, it is actually dipped. The pencil will be actually dipped like this, but you will see it like this. So utha hua dikhega. Clear? Many of you might have on holidays gone to Ooty, Paikara Lake, Nainital, and you must have done boating. Have you seen when you do boating and the two rows are inside water, they will all appear terra terra. It is exactly the same phenomenon. Okay. And if you have not done boating, then please do boating with a life jacket on. Okay. Now we come to something called lenses. Lenses. So lenses are not like glass slab. Oh, one more diagram. The glass slab diagram I drew, na, emergent ray and all. So lenses are not exactly glass slab, but they will have a curved shape. In our books and our syllabus, we study only about two lenses, which are convex and concave. But before understanding convex and concave, let us understand what is a plano-convex and a plano-concave, so that our knowledge becomes clear. So let's understand what is a plano-convex lens. Plano-convex lens. Plano word comes from, all of you all are yawning. Plano word comes from the word plane. Not P-L-A-I-N, plain dosa. P-L-A-N-E, plain dosa, plane. Plano-convex lens. Now, the type of lenses that you are studying, when you go to grade 12, they will further classify this as thin lenses. And these are all thin lenses that you are studying. Something like what I'm wearing, what you are wearing on your eyes. These are called thin lenses. A plano-convex lens. Now, you know convex mirror and concave mirror. Convex is whose tummy is bulging outwards, right? So, plano-convex lens will be a lens which will be in this order. Its one side will be absolutely a straight line, and the other side will have a minor curvature like this. This is a plano-convex lens. This is a plano-convex lens. Similarly, you should also know what is a plano-concave lens. Plano-concave lens. A plano-concave lens will have one side which is like a straight plane, and the other side would be just slightly concave. This is a plano-concave lens. Means concave. If you make somebody sit, he should sit under a cave. Remember concave mirrors? Concave mirrors make a person sit. He should feel that he is sitting inside a cave. This was concave mirrors. So this is concave lens, plano-convex lens. In our chapter, we have what, beta? Convex and concave. So what I do, now I take off the word plano from here, and I bring another plano-convex lens, and I exactly match it end to end. Two planos on their plano surface like this. So it becomes a convex lens. And similarly, I take the plano word out from here, and on this side, slides and this. Right? So time to make the diagrams a little bit more beautiful. Yeah.
So in convex lens as well, we have this straight line.
That is the axis. That is the axis of the lens. So we show in that manner. Okay. This and this one would be something like this. And in this class also, have your protectors. They help you draw, but they will not help you so much as they helped you in convex lens, concave lens. Just for our understanding, in lenses, we will be studying more detailed on this one, less on this one, and they'll just behave the same way. Why did we study convex mirror less? Convex mirror creates only one type of image, convex mirror. What was the image? The image used to be erect, virtual, smaller than object. This one will also create same type of erect, virtual, smaller. And just if you want to have little bit of knowledge for all the Anurags and all the others also, because he's more curious, all you guys at this age are having negative power in your eyes. All you guys, 99.99% kids sampled will have negative power. One bacha will have positive. He's a rare find. Looking at that kid itself, you can say his glasses will be very thick, heavy, shiny. All you all are wearing what? Concave. I am wearing convex. Okay. You all are all wearing concave. So do you see the letters ulta in your book? No. but the letters are smaller. How to check it out? Take out your specs. You can do it right now. Take your specs and just put it on your book where you are trying to see. Just put it on your letters. Just put it on your letters are actually smaller, not like that. Through the specs, the letters are smaller. Yes or no? They're all smaller. Just put your specs and put them on the letters are all smaller. Therefore, concave creates only one type of image. Virtual, erect, smaller. But if I take my specs, I am convex. Mine is like a magnifying glass. It will appear bigger. And all this we will study in Human Eye and the Beautiful World, which is really interesting. Chale abhi? So we'll be studying. So let's study lenses and let's study what is the principal focus of a convex lens. Now lenses will have two type of focus. Principal focus or primary focus and secondary focus. Somebody calls it primary focus, secondary focus. So the difference here, the difference for a lens is that if this is my principal axis, right? And say I am creating one more axis out here and I put my lens. If you draw this line, the diagram looks better. That's all. And my lens is here, right? My ray of light, in the case of mirror, one side used to be unpolished or one side used to be the rough side. So in a mirror, the ray can be incident from only one side. We used to keep the rays incident from the left hand side. Here also we will keep the rays incident from left hand side. But children, tell me one thing. A ray can come like this. The ray can come in this manner also. But in mirror, that is not possible. Do you get it? So if they come from this side, there will be some focus. If they come from the other side, then also there is some focus. So in a lens, you will always get two focuses, right? The one, but question arises, sir, which side you will take the rays? Well, I will always follow the sign convention diagram. That means for me, the rays will always come from the left hand side. Based on that, the focus that I get, I will call it the primary focus or the principal focus. Then there will be one more focus that I'll call as the secondary focus. Itna samajh mein aaya, right? So, principal focus. So, how do I see the principal focus? Now, since you are familiar with image diagram, then the incident rays will always travel from the left hand side. Acha, tell me one more thing. Can the incident ray not travel from here? It can. But for mathematics, we will take it in this side, right? And all measurements along this direction, along the direction of, see, we used to study in mirrors as what? All measurements are done from the origin. All measurements to the right are positive. Hey, Shreya, okay na? Understanding? Okay, all measurement to the right are positive. Now we will change our words. We mean the same thing, but we are a little bit more matured. We will say, all measurements along the direction of the incident rays are positive. Baat to ek hi hua. All measurements in the direction of the incident ray are positive. Whenever you are opposing the incident ray, the measurement will be negative. That is, you are going this way. Okay? So let's have a look at the convex lens. Instead of pole in convex in lenses, we have something which is known as the optical center. We don't have pole, we have optical center. The principal axis remains the same. Right? The principal axis remains the same. We have a pole, we have an optical center, the principal axis remains the same. Are we fine? Okay. No, वो नहीं बोल सकते. It is optical center. Resembling like pole there. Pole was the center of the mirror. This is the center of the lens. This is inside the lens. You can see it. Okay. समझ में आया? So we start our diagram in the same way. We take parallel rays which are close to the principal axis, right? Rays which are parallel and close to the principal axis. This will behave just like concave mirror had behaved. If you are fine with mirrors, you should be super fine with lenses. Okay, you draw. I'll give you enough time because I have to fill water and drink. Let me just say what I want to say. Look at me once, children, and then you keep drawing. I have to fill water. The principal focus of a convex lens is a point on the principal axis at which rays parallel and close to the principal axis converge. You can say meet, but we'll use a better language called converge upon after being refracted, not lected, after being refracted by the convex lens. So this lens will also be known as my converging lens. By this time you keep drawing. Let me fill some water. Principal focus of a convex lens. The principal focus of a convex lens is a point on the principal axis at which rays parallel and close to the principal axis converge upon after being refracted by the convex lens. Converge upon. Ishita, just don't do one thing, that is, don't make double. Don't sketch it. In physics, you are allowed to have only 1 mark. No shading. Understood? The principal focus of a convex lens is a point on the principal axis at which rays parallel and close to the principal axis converge upon after being refracted by the convex lens. Now my second question to you, how did you get this point? By actual intersection of rays. Therefore, this principal focus will be also a real focus. Just like concave mirror, it's a real focus. Right? The distance OF will be known as my focal length. Is known as my focal length. Clear, bacha? Denoted by F. So many things you have to write. I hope you could write the definition on your own, right? The principal focus of a convex lens is a point on the principal axis at which rays parallel, incident rays, parallel and close to the principal axis converge upon after being refracted by the convex lens. Such a focus is a real focus because actual intersection of rays happen here. Clear? In mirrors, you used to have something called F and C, and the relation you used to use was the radius of curvature is twice the focal length. But here you don't have C. Here you have something which is known as 2F. We will have another point which is known as 2F. F, 2F. We will not have C out here because C is the center of curvature. Here you don't have a center of curvature. But the center of this mirror lens will come in grade 12. There will be 2 centers. For this surface, you will have 1 center. For this surface, you will have 1 center. But those all will come in grade 12, not now. Understood? So, in the same way, if the rays would have come from this side, the rays can come from this side also, no doubt about that. There will always be a focus on this side also, which is known as my secondary focus called F dash. And I can also have a 2F dash. This is the primary focus or the principal focus. This is the secondary focus. This is not something that is virtual and all. This is also real. Just for the case of the geometry of ray optics, we take the incident rays from this side. Otherwise, what am I wearing? Convex lens. I should be able to see only in this direction. ऐसा होने से चश्मा उल्टाना थोड़ी पड़ेगा. ऐसा नहीं है. ठीक है ना? Rays come on both sides. Any doubts so far? Okay. Another thing which we don't study in grade CBSE, but you should know because somebody of you will have love for camera and all. Children, the portion of the lens that you actually expose to the incident rays. Let's say our lens is such that we have covered the lens at this position and this position, and we are exposing only this much portion. We are exposing, say, only this much portion of the lens. Only this much portion of the lens I have exposed to incoming light. Do you get it? Only this much portion. Baki portion, say, suppose I have covered it. And that's what we do in camera. This portion AB will be known as this is known as the aperture. Very important term in photography, aperture. Aperture actually controls how much light the camera is ready to receive. Like today, it's very, very hot and sunny outside. Now, if you open the entire aperture and click pictures, you will get blurred pictures. Blurred means extra bright. We don't want that. So we have to reduce aperture. Aperture, shutter speed, and focus. These three are the playing things in a camera's photography. Whoever has good control on these three, he'll click good pictures. Okay? Concept of aperture samajh mein aa gaya. Now, you remember we had discussed something called focal plane. So understand, if this is the focus, I'm just drawing an axis out here. Okay, I'm drawing an axis out here, and say this is an axis. Now try to put one plywood or one big drawing board on this particular axis. That drawing board can have infinite length, infinite width. That plane is known as focal plane. Clear hua? That drawing board will be known as the focal plane. Question arises, sir, do you expect rays always to come parallel to principal axis? No, rays may come parallel but not parallel to principal axis. In that case, where will they merge? They will merge on the focal plane. They will not go out of the focus. The focus is the intersection of the principal axis and the focus axis. They will be on the focal plane. So if I mutate this diagram a bit, I can use different colors on this software. So say suppose I have a ray which is coming like this. Okay. I have another ray, just for your understanding purpose, which is say coming like this. I have another ray which is coming parallel. Rays are parallel to each other, but they are not parallel to the principal axis. The rays are coming like this. I expect all these rays to converge, but they won't converge on the focus. They will converge somewhere on the focal plane. They will converge on the focal plane. Is it clear? You'll still converge on the focal plane. So what all did you learn here? You learned what is the primary focus or principal focus of a convex mirror. You learned what is focal length. You learned what is the nature of the focus, real focus. You also learned that there can be a principal focus, there can be a secondary focus, primary or secondary. And there is another measurement taken as 2f, which you used to take as F and C in mirrors. Clear? Shall we go to primary or principal focus of a concave lens? Any question? Anybody out here? Hey, sona nahi hai. Whenever you feel sleepy, take your fingers, put your pencil, squeeze it, and your sleep will go. Okay, chalo. Next. Okay. Arey, enjoy the day. Bye. Now we are going to study this for a concave lens. So first make your principal axis. Very good. Then you make the lens axis. Very good. Now you make your lens. Our lens is ready. Optical center O. Then draw some parallel rays parallel to the principal axis. Oh, all you RCB fans, what happened yesterday? Arey, look at those traitors in Ahmedabad. Whole stadium got filled up and they are supporting RCB in Ahmedabad. All wearing. People went from Mumbai to Ahmedabad to watch. Bowler does not become that happy that Virat Kohli becomes happy. And cameraman is totally paid. Anything happens, focus is. Kya re, Amish, agree or not? Anytime camera is on Virat Kohli. As if he is the guy who is playing. Leg before, cameraman shows him. He is neither wicket keeper, neither he is the bowler. Those are the two persons who are supposed to appeal. All cameras are like autofocus on him. And then he'll, and look at those people when RCB. Are Kalna. I had 2 kulfis at a time. Especially when Tewatia hit that 1-4 and Holder hit that 6. It was like, interesting moment. Who wins the IPL is nothing of my concern. My only concern is RCB should not win. That's it. Okay, children, I am drawing it in a little bit means illegal way just to make the diagram look correct. But I'll explain you what is the correct way to draw it. By now you have understood. The principal focus of a concave lens is a point on the principal axis from where incident ray parallel and close to the principal axis appear to diverge out after being refracted by the concave lens. Here refraction happens. So they are diverged out. But where did they diverge out from? They diverged out from this point F. So such a lens will be known as a diverging lens. भटका देता है, भ्रमित करता है. Diverging lens. The principal focus of a concave lens is a point on the principal axis from where incident rays parallel and close to the principal axis appear to diverge out after being refracted by the lens. By the lens. What lens? Concave lens. So, couple of understandings out here. This will be known as a virtual focus. You know virtual? My English is very bad. Virtual. Virtual focus. Because no actual intersection of rays are taking place. So, bacha, just see. If F is on this side, the 2F will be out here. Similarly, we will have a secondary focus F dash on this side and a 2F dash also on this side. Clear? Some things which we would also like to say, since now you know sign convention and you know what is focal length, and you know what is focal length. So what happens? You know what is focal length and you know what is sign convention. If you look at this focal length, this will always be a negative focal length. But if you look at the previous focal length, this will be a positive focal length, right? So I will write that statement also because you know sign convention now. I will write F is positive out here, whereas Here f is negative. Any doubt in these two understanding? F is the focal length. The focal length is positive and the focal length is negative. Samjhing? So what all did you learn? What is a concave lens? What is the principal focus of a concave lens? It is a point on the principal axis from where incident rays parallel and close to the principal axis appear to diverge out after being refracted by the lens. You see, now this is one chapter notes of grade 12. They have got, see, perforated. Years after years I use them. And if you make it properly at the end, you can also make them like at the online bachas to cannot see. See, the chapter formulas can be like this. Then I don't need any textbook to read. And so many years, it gets into you. Anything, any formula, see. And write it in proper manner. And then make perforated holes. This is not A4, this is a full-scale paper, legal paper. So make holes and you keep it. If you revise this is more than enough. Anvita, देखना ये बंद नहीं हुआ. Fine. So far. With this we move to image formation. And in image formation, we will deal only with, will not go too much, just some simple rules. So we, yes, sorry. Done. Okay. Image formations and all we will take next class, but some intro gyan. First, we will understand image formation rules for convex lens. Image formation rule for convex lens. Right? So make one diagram and replicate it. That is one lens, principal axis. Fine. We will revise this next class also. आओ देखते हैं. If you see, you will get to know. Very easy, just like mirrors. Just like mirrors. So we, by that time, let me point the focus also. F. 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 O. 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 Ready, children? Aaja. Rule number 1. Quickly, and we will do it next class also. Don't worry. But that does not mean you don't pay attention. You do pay attention. Rule number 1. Look at here. Look at me. What was mirror's first rule? Ray parallel to principal axis passes through the focus. Here also same thing. Ray parallel to the principal axis. And this is the rule on the basis of which you found the focus. Passes through the focus. Right? Understood? Bacha? No issues. So we'll have a F dash on this side also, focus. So the next rule, a ray through the focus becomes parallel to the principal axis after refraction. After refraction, huh? Rule number 2. Rule number 1, rule number 2. Understood? Rule number 3. What was it? If you pass through the optical center, you go undeviated. Is there any rule 4? Mirrors, lenses don't have any rule 4. What was rule 4 in the case of what you call, if you see mirrors was parallel through the focus. through the focus parallel. Angle of incidence at pole is same as angle of reflection. A ray through the center of curvature comes back in the same path. ये और ज़्यादा easy है. यहाँ पे you need to study only 3. Are they clear? They're pretty easy, right? A ray which is parallel to, with this you actually define the focus. This is just the reverse way, right? And this one says, and with that, I rest my case. Defense rests his case. Your witness, please. My witness is my bed. Shreya, you must be having, who all have bed ready means right after the class. Get into the bed. Aditi, all senses behaving normal, eyes, nose, ears, good. Don't touch any electrical appliances for next 1 hour till you come to normalization. Amish, ठीक है सब? बढ़िया. Next class से हो जाएगा. You'll get a habit of it. So we'll close here today. And next class we will get into numericals. Sign convention we know. And the formula. Lens has E. So here we'll have negatives E. Perfect. So you can note down. I'm just closing the recording.